Hello friends, in this video we will learn about how to calculate power requirement when you are climbing some stairs, and this we will illustrate using a problem. So this problem says a 50 kg marathon runner runs up the stairs to the top of Chicago's 443-meter tall Willis Tower, the tallest building in the United States. So this is the Willis Tower, and the height of this building is given, and this height is 443 meter. Now a runner wants to go onto top of this tower. So basically she wants to climb using the stairs to the top of the tower, and the mass of a runner is also given. So this mass is equals to 50 kg. So the question says to lift herself to the top in 15 minutes, what must be her average power output? So she wants to go onto top of this tower in 15 minutes. So time is also given, that is 15 minutes. And you have to find what is the average power output, that is P average. That is the target variable in this problem. So in other words, you have to find what is the power she should generate so that she can safely reach to the top of this tower. Express your answer in watts, kilowatts and horsepower. So the final value that you will get, you have to express in terms of 3 units of power. So power is often expressed in terms of watt or kilowatts or horsepower. So basically in this case you have to convert in these 3 units. The final answer you have to give in terms of watt, kilowatt as well as in terms of horsepower. Now how will you do this problem? So if you remember, power is given as F dot V. So force is a vector quantity, velocity is a vector quantity, but if you take the dot product, power is a scalar quantity. Now the same expression I can also write F dot velocity, I can write displacement divided by time. We can also rewrite F dot S and this divided by time. And if you remember, F dot S, that is nothing but work done. So I can write work divided by time. So you can calculate power by 2 ways. In first method, what you can do is, you can calculate all the work, that is work done by this bowman going from bottom to the top of this tower. And then you divide by time taken. So in this case time taken is 15 minutes. So you divide by time taken and then you will get the average power. So this is first method of calculating the power. You can also directly calculate power because you know how much force she has to generate or she has to apply to go onto this top of this tower, and you know the velocity, then you can calculate the average power. So this is the second method of solving the problem. Now in this video we will solve this problem using both methods. So let us first discuss method 1. That is power is equals to work done divided by time. So how much work she has to do when she is going from bottom to the top of this tower. So this is bottom and this is top of this tower. So how much work she is doing? So basically she is applying a force against mg. So her muscle and everything is applying a force against mg because she has to overcome mg, and we are assuming that there is no change in velocity. So she is going very slowly and basically there is no change in velocity. So constant velocity. So you can basically calculate what is the work because she always remains in equilibrium. The upward force applied by her is equals to weight. So how much work C has to do when C is going from bottom to the top of this building? So C is doing work against gravity force, that is equals to mg, and the height C is traveling is h. So work done will be mg into h. This you can also understand because there is a change in potential energy when C is going from bottom to the top, and that change in potential energy is equals to mgh. Since there is no change in the kinetic energy, we can say the work done is equals to change in potential energy, that is equals to mgh, and then I have to divide by time to get the power. So let us calculate the numerical value of work done, that is equals to mgh, because we know value of mass is 50 kg, and gravity, that is 9.8 meter per second square, and height of this building is given, that is 443 meter. Now if you calculate all this will come 2.17 into 10 to the power 5 joule. Now if you want to find power, that is average power, you have to use this formula, that is work done divided by time, that is mgh divided by time, and we calculated the value of mgh, and that value is 2.17 into 10 to the power 5 joule, and time we have to plug in seconds, so 15 minutes is the time, and then we have to multiply by 60, so this is time in second, and if you calculate all this will come 241 watt. You can also express your answer in terms of kilowatt, that is 0.241 kilowatt. Finally, you can also express your answer in horsepower. So if you remember, 1 horsepower is equals to 746 watt. So in other words, if you divide watt by 246, that is 746, so 241 divided by 746, this will give you power in horsepower, so 0.323 horsepower. So in this case answer will be 241 watt, or you can say 0.241 kilowatt, or you can say 0.323 horsepower. Now in the second approach we can use force dot velocity. So let us discuss second method by which we can solve the same problem. That is, so we have method 2. So in this case what we can do is we can calculate power average, simply force dot velocity. Now in this case we have to take average velocity, because this velocity, basically in this case we are assuming this velocity is constant, and we have to take the average velocity. So we know the average velocity in this problem, that is given, or in other words we can calculate using height divided by time. So let us first find average velocity. So average velocity will be total height, that is 443 meter, and this divided by time, that is 15 into 60, because I have to convert in second. So this will be 0.492 meter per second. So this is the average velocity. Then I can calculate average power and how much force C has to apply. So C is going up. So if you consider at any point, if you see the equilibrium of this person, mg is acting in the downward direction and C has to apply a force in the upward direction. This is coming from her muscles. So F minus mg is equals to 0. So this means she has to apply a force of mg in the upward direction. So force magnitude is mg and we just calculated velocity. This is 0.492 meter per second. And then when we are taking dot product, we have to multiply by angle cos phi. That is the angle between force vector and velocity vector. So in this problem, force is in the upward direction and velocity is also in the upward direction. So average velocity is also in the upward direction. So there is an angle of 0 degree between force vector and velocity vector. So cos phi is basically cos 0 degree, and you know the cos 0 degree is equals to 1. So this simply, so power average is simply mg times 0.492 meter per second. Now mass is given, that is 50 kg, and gravity is also given, that is 9.8 meter per second square, and then you have to multiply this by 0.492 meter per second. So if you calculate again, this value will be 241 watt, and you can convert this into a kilowatt or in horsepower as we calculated in method 1. So in short, you can use both method to calculate the average power. So either you calculate the total amount of work done and then divide by the time, that will give you the average power output required to go from bottom to the top of this tower. In the second method, what you can do is you can take the force and it multiply by the average velocity. So either you can use force dot velocity formula or you can use work divided by time formula. In both cases, you will get the same answer. One important point in this problem is, this is saying average power required. So in this problem, the average power required is 241 watt. But this person has to apply basically more force, or in other words, she has to generate more power. Why this is so? Because when she is going from bottom to the top, she is not only covering this height, basically she also has to breathe. She also has to inhale, exhale. She has to swim his legs and hands. So all this will take energy, all this will require some power. So some power is wasted. So she has to basically apply more effort, or in other words, she has to generate more power so that she can go to the top of this tower. So minimum power requirement is 241 watt, and she always has to generate more power than 241 watt. Otherwise, she will not be able to inhale, exhale, or swim his hands or legs. So I hope you enjoyed this video, and if you enjoyed, please share and like this video, and I will see you in the next video. Thank you.